A very warm welcome, my dear children. We are in the fifth part of a lesson, metals and non-metals. Now we are going to start with activity 4.6, page number 49. You can see in the activity how metals react with metals and non-metals with acids. So here you can see a tabular column, table number 4.5. They have taken some 6 test tubes and just named it as A, B, C, D, E and F. In A test tube they have taken magnesium ribbon, in B test tube they have taken aluminium foil, in C test tube they have taken iron fillings, in D test tube they have taken copper peeled wire, or just you can say it is a flexible wire. In E test tube they have taken charcoal powder, and F test tube they have taken sulfur powder. Now we are going to react with two types of acids. So you can see magnesium, aluminium, iron, copper are metals. Charcoal and sulfur are non-metals. In charcoal you can have carbon as a non-metal and sulfur is a non-metal. Here you can see two columns are there. At room temperature what type of reaction is observed, and even at warm temperature what type of reaction is observed. Let me tell you, when metals just react with acids they produce hydrogen gas and salts. So here is a just observation, you can write, just note down these changes in the tabular column. Magnesium ribbon, when it is added to 5 ml of dilute sulfuric acid or dilute hydrochloric acid, the reaction takes place to produce hydrogen gas. Here we can just identify the hydrogen gas as just bringing a burning splinter or a matchstick near to the mouth of the test tube. So what you all should do is, just imagine when you take a magnesium ribbon containing test tube and label it as A and add 5 ml of dilute hydrochloric acid. I mean to say here dilute hydrochloric acid means concentrated acid. When you add some water, I mean when you dilute it, we call it as dilute hydrochloric acid, or when you add water to sulfuric acid we say it as dilute sulfuric acid. There is a procedure for adding acid to water, children, that you will get in your higher standards. So what you all should do is, when you see magnesium ribbon reacts with a dilute HCl to form magnesium chloride salt and hydrogen gas. When you bring a burning splinter near to the mouth of the test tube, it just burns with a pop-up sound. This indicates the gas is a hydrogen gas. The reaction takes place even at room temperature, and when you warm the test tube, the reaction takes place very rapidly. Magnesium ribbon reacts with dilute sulfuric acid even to produce magnesium sulfate as salt and hydrogen gas. When you warm this, the reaction speeds up. So that is a rapid reaction. When you take aluminium foil in test tube B and react it with 5 ml of dilute hydrochloric acid, it produces aluminium chloride. Even at room temperature, the reaction takes place. And when you warm this, you just get a rapid reaction, means a fast reaction. Even with the dilute sulfuric acid also, aluminium foil produces aluminium sulfate and hydrogen gases formed. Iron fillings also produce iron chloride with hydrochloric acid and releases hydrogen gas. When you warm the reaction, it is a rapid reaction. Even iron fillings react with dilute sulfuric acid to produce iron sulfate and hydrogen gas is released. Whereas in the copper is a D. When you take test tube D, it does not react at room temperature because it is a weakly reactive metal. And even copper does not react with dilute sulfuric acid, no reaction takes place. Whereas for non-metals such as carbon, that is charcoal powder, and sulfur also does not produce any salts because non-metals does not react with dilute acids. So therefore no reaction takes place. You can see here a small changes as copper does not react with dilute hydrochloric even on heating, but it reacts with it reacts with sulfuric acid to produce copper sulfate. Now we are in the next part of lesson activity 4.7, reaction with bases. When you see metals react with bases to produce basic salts. So now let us perform an experiment for this. You can see here small aluminium foil under sodium hydroxide solution. You can just take some water in the glass beaker and add small amount of sodium hydroxide and add aluminium foil to it. You can see it forms just a pellet. You can see it is forming a sodium hydroxide salt which is made up of sodium aluminate, Na2Al O2. We call it as sodium aluminate, and it releases hydrogen gas. You can just identify the gas as hydrogen when you bring a burning splinter near to the water beaker in which the reaction is taking place. It burns up with a pop-up sound. Pop-up sound means you can just imagine how the crackers will burn. With that sound, it starts to pop up. So this indicates that the bases reacts with metals to form sodium aluminate when sodium hydroxide is used. Non-metals also react, but you will learn those in the higher standards. Next we have displacement reaction, a very important one. Displacement means when a highly reactive metal reacts with a less reactive metallic salts. Children, when a highly reactive metal reacts with a less reactive metallic salt, it displaces the less reactive metal. For this, let us experiment or let us perform an activity for your better understanding. Here also, take 500 ml beakers and label them as A, B, C, D and E. Take about 50 ml of water in each beaker. Dissolve in each beaker a teaspoonful of the substances and keep the beakers undisturbed for some time. And now observe the observations. In beaker A, copper sulfate is mixed with zinc granules. Copper sulfate is blue in color. You can see a blue colored solution in A. In that, add few pieces of zinc granules. In B, see children, in beaker A, copper is less reactive than zinc. So therefore, zinc displaces copper from copper sulfate. That is, when you see CuSO4 plus zinc, it produces ZnSO4 plus Cu. That means a copper is precipitated on the zinc. Now next, in beaker B, copper sulfate is taken and blue colored solution, just put an iron nail. When you see this, after some time, the iron nail will be deposited with red color copper. This means copper is less reactive than iron. In beaker C, put white colored zinc sulfate and add red color copper turnings to it. You can see no reaction takes place because zinc is highly reactive. Copper is less reactive than zinc. So therefore, it cannot be added. So the displacement reaction will change. That means there is no change in beaker C. Next, D, iron sulfate with copper turnings. And in beaker E, zinc sulfate plus iron nail. What changes do you observe? You can see in beaker A, zinc replaces copper from copper sulfate. That is why blue color of the copper sulfate disappears and a red mass of the copper is deposited at the bottom of the beaker. The reaction is represented as CuSO4 copper sulfate, which is blue in color, plus zinc metal gives rise to zinc sulfate ZnSO4 plus copper red in color. So there could be a displacement reaction of copper. There you can see displacement of zinc by copper in beaker C and iron in beaker E. Similarly, iron could be displaced by copper in beaker D. Since we do not see any change in beaker C, no reaction takes place. Zinc is more reactive than copper, so the reaction does not takes place. There are few rules for the displacement reaction to takes place. You can see the reactivity series of the metal. The metals which are upper or the first 5 elements in the reactive series are more reactive than the elements which are at the least or at the end of the reactive series. Children, I am not asking you to learn this reactivity series, just observe it. You can learn in your higher standards. We have come to the last part of a lesson. Metals and non-metals have few uses. We all know that in our daily life we use many things which are made up of metals and non-metals. See, metals are used in making machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, and also many other domestical use things we can make. And also non-metals are useful for us to inhale. Very important thing, children. Do you all know that? Oxygen is used for inhaling. Nitrogen is used for growing plants. Non-metals such as NPK, nitrogen, phosphorus and potassium. Potassium is a metal. Nitrogen and phosphorus are non-metals are used in making of fertilizers. Non-metal is used in water purification, that is carbon. Non-metal is purple colored solution which is applied on our wounds as antiseptic, that is iodine. Non-metals are used in crackers, phosphorus and sulfur. You may add some more uses which you know from your own experiences. Children, this is the end of the lesson. Once have a look at the lesson. I am sending the notes. Thank you.